Hello guys, welcome back. It's again time for another Leetcode problem. This time we are going to solve Leetcode number 200, number of islands. So this problem is on the backtracking category. Before diving in into solving the problem, I'm gonna explain it quickly to you guys. But let's just take a read on the description here. Again, it's a medium level problem. And it says, given an m times n to the binary grid, which means the value can be 0 or 1, which represents a map of 1 means an island or land, and 0 means water. Return the number of islands. So an island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically. You may assume all 4 edges of the grid are all surrounded by water. Yeah, it's a little bit tricky, but what it says is 1 represents land and 0 represents water. They want to know how many islands does this grid have. For example, here there is only 1 island. Let's quick jump to the whiteboard here, where I'm going to quickly draw the example. So let's say this is our grid, which is m times n. It's going to be 4 rows. 1, 2, 3, 4 rows, and we will have 5 columns. 3, 4, 1, 2, 3, 4, 5. Yeah. So let's fill in our grid. So it's going to be 1, 1, 1, 1, and 0. Again, 1, 1, 0, 1, 0, and again 1, 1, 0, 0, 0, and last row we only have zeros, which means water. Okay, the idea here is to get all the adjacent land, which is our number ones, and tell in the answer how many islands we found out. So in this case here we have, this is an island because this is a piece of land surrounded by water, and we can assume that on the edges we also have water. So keep the land here, 1, 1, 1, and then it ends here. So we have 1 island because we found out that all of this land here, they are connected or they are adjacent to each other. Okay, so this is the basic idea. Another example here, just getting again the second example here, where we have 3 islands. Let me delete this one here. Oops. So you have to learn to use this whiteboard, but let's go it again. It's going to be another grid. It's going to be 4 by 5 again. 1, 2, 3, and 1, 2, 3, 4. Now let's fill in 1, 1, 0, 0, 0 here, 1, 1, 0, 0, 0. Now 0, 0, 1, 0, 0, and 0, 0, 0, 1, 1. So how many islands do we have here? So we have 1 island here. They are all connected. We have another island here. It's a single piece of land, but it's, again, it's surrounded by water here. and there is no other one adjacent. So there is no way to reach another number 1 without going to the water. And we have another island here on the bottom right of our matrix. Okay, so this is the basic idea. This is the way we are going to look for these islands. Okay, let me just remove here. And the backtracking idea is to keep going and keep exploring until we satisfy the condition, which is while I'm finding land, I'm just gonna count that as a single island. For example, here, if we start in here, that's gonna be 0, 0. Then we can go to the adjacent and see, okay, it is land. Yes, it is land, so that's fine. We can try going right again and say, oh, it is water, so I have to go back, or I have to backtrack because the next cell does not satisfy our condition, which is I need to find something which is connected. Okay, next step here is we can keep going because we can go either right, left, down, or up. So we are just coming back here. We can go down now, and then oh yeah, it's another piece of land. So that's nice. Another one which is connected. Then we can try going right. Oops, no, it's not. It's water. I have to go back to come back here. So I have to backtrack. And likewise here, I can try going down, but it's water again. So I have to go back. And then I can try going left. And then I will find another number 1. And again, depending on the size of the matrix. So using this one as an example, if I go down here, it's water, so I have to come back. So I backtrack. In this case here, I found 4 number 1s, which forms a single island because they are all connected. Okay, and I have to do the same thing for the whole matrix because I don't know where I have land or water. So I have to go through the matrix and doing that work. Okay, once the algorithm backtracks. So the last step is once we reach the last spot, then the algorithm is going to go back. We are going to use recursion. So it's going to backtrack until we go back to the point where we have started. Then we can start from another cell. A quick tip here is see how we went to the right column here. So we have to keep track on all the cells we have seen already, because we don't want to count that again or count that twice. Okay, so that's the idea behind the algorithm. So now let's deep dive here in the code, and let's solve this question using those ideas. So the backtracking algorithm is basically a depth-first search with the ability to go back and explore a new possibility. First thing we're gonna do here is let's create an array saying visited, because we need to mark all the places we have been, so we don't go there again. I'm also gonna add an instance variable here. So I'm just gonna assign grid to the instance variable. It's gonna point to the grid I'm receiving here. And visited is new. It's a new array. That's gonna be the size of the grid, m times n length. Okay, so this one should do. Next step is to define our total, or a sum. That's going to be the total number of islands we will find. Then we return the total. Next step is to go through the matrix as I showed you guys here. Let me remove all of these marks here. So we have to go through the whole matrix because we don't know where we'll find land or water. So we have to test all possibilities, and of course avoiding the ones we already seen. So that's basically what we're going to do here. So let's go. It's going to be the number of rows less than grid dot length. And okay, keep going to the next row. Also do the same for the columns. So I have to go through rows and columns. C less than grid 0 length. C++. Okay. And then we have to check if that spot has been visited, or is water, or grid RC is equals to 0, then don't do anything. Just go ahead and try the next cell. Then we are going to create here our magical function. I'm gonna call it backtracking, and passing the row and column. After that, just increment the total. So we're gonna have the total times we called backtrack here. And last but not least, our function backtracking that's going to receive a row and a column. So here what we're going to do is basically create and test the constraints for walking the matrix here, which is going to be simply we have to test the boundaries. If the row is less than 0, which means we're just trying going off the grid range, so we cannot do that, or are greater than or equals to grid.length. Again, we're trying to go out of the bounds on the right side, or C less than 0, or C greater than or equals grid 0.length. Okay, or visited RC, or that cell RC is 0. Then if so, simply return, don't do anything. Okay, just come back. So this is the conditions to walk through the matrix. We just start from here, 0, 0, so 0, 0, and then we keep trying to explore all the paths. And yeah, to explore the paths, first of all, we need to mark the cell as visited. And next step is to explore the possibilities. What are the possibilities? Simply, we can go another row or another column. We can go right, left, bottom, or up. We're gonna do that just calling backtracking again. Go to the next row, the same column. Then go to the previous row, same column. Or go to the same row, next column. Or go to the same row and to the previous column. So this is gonna give us row plus 1 down, row minus 1 up, column plus 1 right, and column minus 1 left. Okay. Yeah, I think we're in a good shape here. Let's try it. Yeah, just I have a typo here. Length. okay, it works. So in this example, the output is 3 and expected is 3. So we have 3 islands here. Let me try to submit. And yeah, it works fine. So this is one way to solve the problem using a visited array. That's going to be another O of n. And another way to solve this problem is simply not having a visited. We can delete all of this. And instead of checking the visited, we're going to mark each cell we visited with 0. This algorithm is called flood fill. Whenever we go to a cell, if that cell is a land, we mark that cell as water, which means that was visited, and then we keep going our exploration. So let me also remove that visited from there. There is no more visited here. And instead of visited, I'm gonna mark the grid itself. Okay, let me try it again. It still works, and then I can submit again, so it also works. Okay, it's good to remember that I have to double check with that if you're on an interview, because the interviewer may or may not let you do the flood fill. So if he doesn't, so you have to use a visited array or a set. Okay, I hope you guys enjoyed. Please leave a like, also subscribe to the channel, as it helped us a lot, and leave any comments below if you guys have any questions or anything. Okay, I see you guys in the next video.